So today our topic is monochrome. So in this lecture we try to understand what is monochrome image and how to generate it with OpenCV Python. Okay. So first come to the definition part. Monochrome is an image displaying only a single color or different shades of a single color. So from the name itself it is very clear that monochrome, that is one chrome. So it will only display a single color or the different shades of the same color. Monochrome photography is a photography in which the entire image is recorded and represented by differing amounts of light instead of different hues. So up to now the definition is clear, I hope. I'm repeating again: monochrome, that image which is displaying only a single color or the different shades of a single color. Now, what will be the example for it? Black and white images. Okay, black and white photography is the most prominent example of monochrome photography since it represents the subject in varying shades of neutral gray but includes no other color. So it is thus including only different shades of the gray version, right? So in monochrome photography, tones of a single color are used to represent all the different colors of that image. So what will be the difference between monochrome and black and white photography then? If you got the example that black and white means monochrome image, the difference is that black and white is the most popular example of monochrome photography, but this monochrome photography can also be made up of variation of other single hues such as sepia or cyan, for example. Okay, so black and white is just an example of monochrome image, but you can also consider single hue. About the hue, saturation, and values, I have one lecture on that. You can search in my playlist of digital image processing. There you will find about HSV. So this is the difference. Black and white is an example of monochrome, but monochrome images can be obtained with some other method like separating only single hues. Right. Now let's try to generate one monochrome image with our OpenCV. This is an practical, so I would like to suggest that all of you first open your OpenCV and keep one image, one color image ready for this practical. Now, for this purpose, we are going to use one technique that is known as binary thresholding. And thresholding, based on a threshold value, we try to divide all the values into two, in this case binary, that is two values will be associated, either 0 or 1. So based on the threshold value, we'll try to classify or try to assign all those values only to either 1 or 0. Now the algorithm for binary thresholding, I just explained what is that. For each pixel of the image, if the value of the pixel is lesser than a given threshold, then it will be set to 0. Otherwise it is set to a user-defined value. Now, as we are operating a grayscale image, and I hope you know that for a grayscale image, the pixel values vary from 0 to 255. So we want to convert the image to black and white, then the pixel is greater than that threshold, the value which we want it to be converted is 255. So this is the particular formula. Sorry, this is actually the function. Trace black and white image, CV2 threshold, gray image 127, 255, CV2 trace binary. So you just need to remember this one, CV2 threshold, and these different parameters. Let's see what each of this parameter means exactly. Okay, after converting or after the thresholding process, that image will be stored in black and white image. That this is a variable name for that image. You can give any one of your choice. So naturally, the threshold function allows us to specify these parameters. So the first input of the function is the grayscale image. This one is the grayscale image which we want to apply this operation threshold. Okay, and this second image, that is 127, is the threshold value. And why we are considering this 127 threshold value, because you will see that this is the middle of the scale of the values a pixel in the grayscale can take. That is from 0 to 255, 127 will lie in the middle. So that's why we have taken the threshold value as 127. Then third 255. Okay, this is the third input, and this function receives the user defined value to which a pixel should be converted in case that value is greater than our threshold value 127. If the value is greater than 127, it will be converted into 255. Then fourth is what? This trace binary, as we are using binary thresholding, that's why trace binary. Okay, this is a force input indicating which type of thresholding you are applying. As you know, there are many of them, so we are using binary thresholding, so that's why trace binary. And the output, you will see that there are two of them, trace and black and white. Trace, in this case, we don't want it. We want this black and white image, that is the monochrome image. So black and white image will be stored in that monochrome image that we will display. Now let's open your OpenCV so that we can execute this practical. Okay, I have already written down those statements, code statements. This is the code. You can take a screenshot of this. Each line I have just explained. Import CV2 for OpenCV. Image, I have considered one image, that is girl image, in my image data set of Kaziranga University of in the Z folder. Then first I have converted it into gray image with the function CVT color, CVT CV2 color Bezier to gray. Okay, Bezier to gray is used for converting this original red RGB image into gray versions. Okay, remember CV2, that is for our OpenCV version, and CVT color for this tags. Okay, then now we are trying to resolve this image with this CV2 threshold function. And what type of thresholding we are using? CV2 trace binary. This is binary thresholding, and about the other parameters I have just explained. Now let's display the image one by one. First black and white, then original, then gray image. So that's it. I hope you had written down the statement. Now let's execute them. The code is being executed. It may take time, no problem.